Okay, here's our quick review of Chapter 6 and a few other formulas that we learned in this same unit. Area between two curves, our formula is always area equals the integral from A to B of the top curve minus the bottom curve. Unless you have to do the sideways area, in which case you do the right curve minus the left curve in terms of y boundaries. Your volume by rotation formula is pi times the integral from A to B of big R squared minus little r squared dx, unless you need to revolve around the y-axis, in which case your boundaries are y boundaries and you are integrating with respect to y. Volume by cross sections was volume equals the integral from A to B of the area of one cross section. And the reason we don't say anything more than that there is because our area of the cross sections can be different. It can be squares, semicircles, rectangles, triangles, those kind of things. Within Unit 6, we also talked about slope fields. So when we are doing slope fields, a couple of things to remember. We looked for patterns that are horizontal or vertical. We definitely look for zero slopes. Because if we can find those and identify how we get zero, whether it's x's or y's, that can really help us narrow down. And then also consider positive and negative slopes, especially in terms of quadrants. Within this, we also talked about matching slope fields with solution curves and what graph shape the slope field looks like. This was always parent functions. Okay, and if you need to, notice your asymptotes to kind of help you out on that one. Also, this page. So for our miscellaneous formulas. Within these miscellaneous formulas, we talked about derivative of bases other than e. So the derivative of a to the x is itself times the ln of the base a, which means when you integrate, you get a to the, oh, that's further down here. So the derivative of a to the u would be itself times ln of a times the derivative of u, or u prime. If we were integrating things other than base e, this is where we used the a to the x over ln of a plus c formula. So a couple examples of that. If we were doing the derivative of 5 to the x, that would be itself times the ln of 5. You saw that show up in your practice exam. Or if it was 2 to the 3x, it would be itself times the ln of 2 times the derivative of the exponent 3. So kind of like a long chain rule on that. If we're integrating 3 to the x, it would integrate to itself over the ln of 3 plus c, of course. And in this case, this one's almost like you're looking at the u prime sitting out here with the u being the exponent. So you're going to integrate 4 to the sine x times cosine x as itself divided by the ln of the base. But the u prime that was multiplied by that kind of goes away as we go backwards. We also talked about inverse trig function derivatives. And you see here your derivative for arc sine and for arc cosine and arc sine of u. Arc cosine is the same thing as arc sine, but the negative. So it is the negative versions of these. We did not really talk about these 3 just because they were the negative versions of the other ones and they were less common. And same thing for arc cosecant. I would maybe take a look at these formulas before, but it's kind of one of those things that if you get to it, great. If you don't lose your mind over it. So if we did the derivative of arc tangent, this is using your u formula here, where we would do u prime over 1 plus u squared. So the derivative of this would be over 1 plus the 2x all squared with the u prime, the derivative of the 2x on the top. Same thing for arc sine here. Your u in this case is x over 2. So your formula for this one tells you it's u prime, so the derivative of x over 2 is 1/2, over the square root of 1 minus x over 2 all squared. So then if we look at the integrals of them, these just go backwards. Your 1 over 1 minus x squared, or square root of 1 minus x squared integrates to arc sine of x. Your 1 over x squared plus 1 integrates to arc tangent. And your those same versions but with u's, this would integrate, this first one would be integrating to arc sine of u over a plus c. And the second one would be 1 over a arc tangent of u over a plus c. So in this case, down here, number 1, this looks the most like your arc sine formula, only in place of the a right here is 2 squared. So when you integrate, you would say my integration becomes arc sine of x over 2 plus c. The tangent one, the a is always going to be your number. So this is root 2 squared. And this x is your u. So that is 3x squared. So when we integrate that, we use our formula of 1 over the a. You also have to include the derivative of your u. So that brings us a 3 out front over top of that. And then we would have arc tangent of, not x, but 3x over root 2 plus c.